Hi there, welcome back to Green School. Today we'll be doing a partial walkthrough of Cambridge International AS and A-Level Computer Science for Paper 3 Advanced Theory. We'll be doing the 961/31 variant for the October/November 2024 series. For this walkthrough, you'll need a question paper as well as the mark scheme. Feel free to download them from my platform whereby I have all the variants for the 9618 exam, including a specimen paper, and the download link is in the description below. And now, let's get started. Numbers are stored in a computer using binary floating point representation with 10 bits for the mantissa, 6 bits for the exponent, 2's complement form for both the mantissa and the exponent. Calculate the normalized binary floating point representation of positive 201.125 in this system. Show your working. This is the typical conversion question from denary to binary floating point. First of all, on the left here, I will put all the binary numbers here to help with our calculation. In order to get 201.125, we will first calculate how to get to this number by adding all the numbers shown on the right here. It should be relatively straightforward for you since you have learned about this back in chapter 1 of this syllabus. I've done a calculation and 201.125 is equal to 128 plus 64 plus 8 plus 1 plus 0.125. If you look at the right here, I have put 1 below the respective number, resulting in 1100.1001.001. Since this is a positive number, we will add a 0 on the left, resulting in this final number of 0.1100.1001.001. And for the last step, we just have to convert this into normalized form, resulting in 0.1100.1001.001 times 10 to the power of 8 here. So for the exponent, we can just fill in 0.1100.001.0010. Take note that we'll lose some precision here, missing this 0.1 at the end here. And for exponent, we can just fill in value 8 here, resulting in 0.01000. For B, calculate the denary value of the given normalized binary floating point number. Show your working. First, we'll write 1.010110011 times 10 to the power of 5 here, resulting in 101011.0011 here. As usual, on the right here, I will write down the binary representation here. Then let's fill in the 1 based on the calculated value here. So we have negative 22, 8, 2, 1, 0.125, and lastly 0.0625. Then the last step is easy. We just have to sum them all together here, resulting in negative 20.8125 here. Reduced Instruction Set Computers RISC is a type of processor. Identify 4 features of a RISC processor. The first feature will be based on the name itself, which is reduced instruction. So we can write low number of instruction sets. Next will be user's fixed length instruction, and each instruction only requires 1 clock cycle. And lastly, it also makes extensive use of RAM. For this question, if you memorize the definition and difference between CISC and RISC by heart, it's actually a 3 marks question. Describe circuit switching as a method of data transmission. Another definition question. First, we can write a dedicated circuit is required as shown on the red line on the right here. Next, the circuit is established before the transmission begins. And to get the last mark, we can just write the circuit lasts for the whole of transmission. By the way, if you are taking my fast track program, you can see that for each question, I will list down the chapter and their respective topic name. Feel free to go through the topic again in my program if you are unable to answer or record certain topics at this point of time. Next, state 1 benefit and 1 drawback of circuit switching as a method of data transmission. The major benefit of circuit switching compared to packet switching would be the whole of bandwidth is available. And the drawback is also due to its benefit, which is bandwidth can be wasted as it cannot be used by other messages. The TCP/IP protocol may be viewed as a stack that contains 4 layers: application, transport, internet, link. Describe how the layers of the TCP/IP protocol stack interact with each other. If you look at the picture on the right here, we have application at the top here and link at the bottom here. In general, application layer is a layer whereby us, user, will use application to interact with the subsequent layers. And the bottom link layer here will be the hardware layer. For this question, we just have to write some description of this protocol stack here. We can start with each layer can only accept input from the next higher layer or the next lower layer here, meaning that let's say transport layer can only take data from either the application or internet layer, but not the link layer here. Then the interactions are carried out by install software, and then user interaction takes place at the application layer of the stack through protocols associated with that layer of the stack. So for application layer, we have protocols like HTTP, FTP, POP3, SMTP, and etc. I hope you can recall what each protocol does as you go through this walkthrough together with me. Finally, direct access to hardware takes place at the link layer of the stack. So this is how you can score 4 marks for this TCP/IP protocol question. Explain what is meant by a hashing algorithm in the context of file access. This is a 3 marks question here, so we have to write at least 3 points related to hashing algorithm. We can start with by writing is a mathematical formula, and then it's used to perform a calculation applied to the key field of the record being searched or stored. Finally, we can just write the result of the calculation gives the address where the record should be found or stored. For this question, if you know how hashing algorithm works, you should be able to score 3 full marks by writing the relevant description. For B, the use of a hashing algorithm can result in the same storage location being identified for more than one record. Outline 2 methods of overcoming this issue. For this syllabus, we'll learn 2 methods. The first one would be the record is stored in the next free memory space after the one identified by the hashing algorithm. And the second method will be an overflow area is set up and the record is stored in the next free memory space in the overflow area. Describe the user-defined data type set. So what is a set? We can write a set user-defined data type is a composite data type. For this syllabus, we mainly learn 2 user-defined data type, which is composite data type and non-composite data type. Then we can get additional point by writing which includes a list of unordered elements. Take note that for set, we don't have to arrange in order. Finally, all the elements are of the same data type. For B, write pseudocode statements to declare the set data type symbol set to hold the following set of mathematical operators using the variable operators. This is quite a doable question if you know the set pseudocode definition by heart. So this is the format of defining set. We will first create a new data type with a new name, and we will need to tell what type of data we store in this new type here. Then we can just define the variable name with the values inside by using this new data type here. Feel free to pause the video now and do it on your own first. So we'll write type symbol set is equal to set of char here, and then define operators with all the operators requested in this question here. Take note that we use a single quotation to indicate that it's a char, and then we'll just write colon symbol set, which is the new data type name. I hope you are enjoying the walkthrough so far. If you find that you have learned something new from this tutorial, just give this video a thumbs up so that I know that my video is helping students like you. And if you are looking for a quick and efficient way to master Cambridge Paper 3 or Paper 4 exam, feel free to check out my fast track program at www.hagwin.school. And now let's continue with question 7. The truth table for a logic circuit is shown. Write the Boolean logic expression that corresponds to the given truth table as the sum of products. This is the typical Boolean algebra question they learned back in paper 1. So we'll start by highlighting the row that gives output of 1, starting with the second row, and the input will be not A and not B and not C and D. And then the next row here, the next row here, this row here, second last here, and finally the last row here. And then we can just put all the relevant input into T, resulting in this solution here. It's quite an easy question if you can remember what you learned back in paper 1. Complete the Karnaugh map, K-map for the given truth table. So I have copied the answer in A on the right here. Then we can just fill in the table accordingly. So first of all, we have 0, 0, 1, so it will be this one here, and then 0, 0, 1, 1 here, and then 1, 0, 0, 1, so it will be this one here, and then 1, 0, 1, 1, so it will be this one here, and then 1, 1, 0, 1, so it will be this one here, and then finally 1, 1, 1, 1, so it will be this one here. And then we can just fill in the remaining empty boxes with 0 here, resulting in this final solution here. For C, draw loops around appropriate groups in the K-map to produce an optimal sum of products. For this question, we just have to find all the overlapping circles with the power of 2. So the first one will be these 4 ones here. and the second one will be from the left end to the right end here, as shown in the blue line here. For DI, write the Boolean logic expression from your answer to part C as the simplified sum of products. So for red one, we can write down all the matching equation first. Then realize that A and D share the same value, resulting in A dot D here. And then for the blue one will be this equation here. And then the common multiplier will be this B and D here, resulting in not B dot D here. Therefore, the final T will be A dot D plus not B dot D here. Use Boolean algebra to write your answer to part DI in its simplest form. We just have to simplify this equation here, resulting in D dot bracket A dot not B here. Describe the process of segmentation for memory management. For segmentation, we can write, in segmented memory, the logical address space is broken into varying size blocks called segments. If you look at the diagram I show on the right here, the segment can be different size. Next, each segment has a name and size. Then we can write segments are numbered as shown in the table on the right here. To get the last mark, we can write a segment map tables maps logical addresses to physical addresses. So if you can remember the diagram on the right here, you just have to convert this diagram into wording form. For B, explain what is meant by this thrashing. When we talk about this thrashing, it will be related to the topic of virtual memory. So we can write this thrashing is a problem that may occur when virtual memory is being used. As the main memory fills up, more and more pages need to be swapped in and out of virtual memory. And the result will be this swapping leads to a very high rate of hard disk access, resulting in excessive disk head movements. A veterinary surgery wants to create a class for individual pets. Some of the attributes required in the class are listed in the table. So we have pet ID, pet type, owner telephone, and date register in the class. State one reason why the attributes would be declared as private. The main reason why we need attributes to be private is to prevent access outside the class. So we can write to ensure that the attributes are only accessible using the class own methods or within the class. And then for B, complete the class diagram for pet to include an attribute and data type for the name of the pet, an attribute and data type for the name of the owner, a method to create a pet object and set attributes at the time of registration, a method to assign a pet ID, a method to assign the date of registration, a method to return the pet name, a method to return the owner's telephone number. Then they have declared 4 variables for you. You just need to declare 2 more variables. So this is a typical OOP class diagram for paper 3 pseudocode. It's actually quite straightforward once you do it a few more times. We will start with the 2 new variables, which is the name of the pet and name of the owner. So we can write pet name as string data type. So we will follow the convention above, whereby we will capitalize the P and N, resulting in pet name like this. Next will be owner name as string data type. Once we are done with the variable declaration, we will just write the constructor. So we can just write constructor bracket here. Next will be the setter and getter. The first getter will be assigning the pet ID. So we can just write set pet ID bracket pet ID as string data type. Since when we want to set a pet ID, we need to get the pet ID. Therefore, pet ID will be the input variable for this method here. Next will be set date register with date register as an input variable. And then we can just write the getter to return the pet name, which is just the get pet name bracket here. And finally, get owner telephone bracket here. So this is how we can create class diagram for OOP question in paper 3 exam. Several syntax diagrams are shown. This is the typical question for chapter 16. Complete the Barker's number form B and F for the given syntax diagrams. If you look at the operator, it can be these 4 operators here. Therefore, we can write plus or minus or asterisk or slash here. And then for label here, it will be either letter and then digit and then one more digit, or just letter and digit here, because we will be skipping this second digit here. So for label, we can just write letter and then digit and then or letter and then digit here. And finally, for equation here, we can just copy this equation here, which is equal to label is equal to label and an operator and then label here. For B, a new syntax rule password is required. It must begin with a letter or a symbol, followed by a digit and end with one or two symbols. Draw a syntax diagram for password. If you forget how to draw syntax diagram properly, this question is quite kind and already give you examples here. So you can just copy the format on the left here. We will start with the name of the rule, which is password here. And then it can either be letter or symbol. So we can just draw something like this here. Next, it will be followed by a digit as shown here. So we can just combine these two lines into a single line here. And finally, it can either be one or two symbols. You can just copy the digit examples here. So we can just draw one symbol here and then another symbol here. So this is for two symbols here. And let's say there's only one symbol here, we can just add one line here, meaning that we will be skipping this second symbol here. So this is how you can score 3 marks for this question here. For B2, write the BNF for password here. So you can just convert this syntax diagram into BNF form. So how do you do that? You just have to look at the possible options. So the first option will be letter and then digit and then symbol. Second option will be letter, digit, symbol, symbol. And the third option will be symbol, digit, and then one symbol. And the final option will be symbol, digit, symbol, symbol. And then we just have to convert this into wording form, which is this solution here. So password is equal to letter, digit, symbol, and then an or statement here. And then next will be letter, digit, symbol, symbol, and then symbol, digit, symbol, and finally symbol, digit, symbol, symbol. So once you know how to break down a syntax diagram, it's actually not very difficult, and I would say that this question 10 is actually a 3-mark question. The following diagram shows an ordered binary tree. Take note that this is an ordered binary tree using alphabetical sequence. For example, G is before R, therefore is on the left, and then Y is after R, therefore is on the right. Then we'll repeat this logic for the subsequent node here. A linked list of nodes is used to store the data. Each node consists of a left pointer, the data, and a right pointer. -1 is used to represent a null pointer. Complete this linked list to represent the given binary tree. For this question, you just have to add the missing node by copying the diagram above into this diagram here. So let's start with orange here. So for orange, it will be on the right of green here. And then this will be -1 here, since there's no data on the right hand side of orange here. And then on the left for orange, it will be indigo here. And then since indigo doesn't have any data below this indigo here, it will be -1 and then -1 here. And let's continue with the red here. So for red on the right hand side, it will be yellow here. So yellow here and then -1 on the right hand side here. And finally will be this violet here. So for violet, there will be no more data after violet, so it will be -1 and -1 here. For B, a user-defined record structure is used to store the nodes of the linked list in part A. Complete the diagram using your answer for part A. For this question, we just have to know location of each color. For example, on the left of red is green here. So where is green? Green's at index 1 here. Therefore, left pointer is 1 here. And then on the right of red is yellow. Where is yellow? Index 2 here. So it will be 2 at the right pointer here. And then green will be blue. Where is blue? Blue is going to be index 3 here. And then on the right hand side will be orange. Orange at index 4 here. And then for yellow will be violet. Violet is at index 6 here. And then on the right hand side is empty here. Therefore the right pointer is -1 here. And then we can just repeat the same process for the remaining rows here, resulting in this solution here. Feel free to pause the video to check if my solution is correct here. And finally, we just have to fill in the free pointer, whereby we can fill in the new value at this index here. So it will be this index 7 here. For C, the linked list in part A is implemented using a 1D array of records. Each record contains a left pointer data and the right pointer. The following pseudocode represents a function that searches for an element in the array of records bin3. It returns the index of the record if the element is found, or it returns a null pointer if the element is not found. complete the pseudocode for the function. This is the typical pseudocode question for searching element within a binary tree. I would say that for this variant, Cambridge board was very lenient when they create this question. Without attempting the solution, you can see that they already provide a if condition here. So the empty if above here, you can just write the opposite. At the same time, they also provide you with the assignment for the null pointer here. So you can write a similar statement at this empty line here. And then the first two blank lines here are typical function definition and assignment, which are just free marks in my opinion. So now let's attempt together. If you look at this function here, it's returning null pointer here. And pointer will be an integer for this use case. So we can write returns integer here. Next, we will start searching the value from the first index of the linked list, which is the value of root pointer here. Then as I say, the subsequent if is less than. So for this one here, we can just write if bin3 bracket null pointer dot data is more than item here. It means that let's say the current element we are looking at is more than what we are searching, we will go to the left. For example, if we are searching green from this binary tree here, we will first look at red here. And then we know that red is more than green. So we will search the left side of the red here. For the next assignment, we will just copy what is shown above here, but change it to right pointer here. Therefore, it will be something like this here. Null pointer is equal to bin3 bracket null pointer dot right pointer here. So let's say if you are searching for yellow now, you just go to the right hand side of red here. And then let's say if we found the value we are searching, it will just return null pointer here. And let's say if you are unable to find the value in the binary tree, meaning that we have exited the loop due to the null pointer being -1, we will return -1. Therefore, this pseudocode can either return the corresponding index if it manages to find an element in the binary tree, else it will return -1. Lastly, if you find this partial walkthrough useful, definitely give this video a thumbs up and share to your friends who will be taking the same exam as you. And if you want to get the best possible grade for Cambridge A-Level Computer Science exam in the shortest possible amount of time, feel free to check out my fast track program at www.hagwin.school. Thank you, and I will see you again then. Bye bye.